Hi, Trunkiel here again. I'm going to go through an introduction to the ultrasonics experiment that you'll be doing as a part of your modern lab experience. Okay, so this is another one of those survey labs where you're going to do a bunch of mini experiments using our new ultrasonics equipment. So what I'm going to do with Dr. Mulhall is just go through very quickly how to collect some data doing the very basic. Let me make sure I get the title of this one correct here. Oh, that's good. It's experiment number 3, and it's a first reflection mode experiment. So you're going to be doing a bunch of reading before this lab. I believe we're forcing you to read about 40 pages of the manual, so when you come in here, you're more, you have a little bit more information about what some of this equipment is doing and where some of the knobs and connections are located. So chapter 3 or experiment 3 is going to be one of the first things you do. So what you're going to do, it's going to walk you through how to connect some of these BNC connectors from the oscilloscope to the ultrasonics equipment and get you to properly display those two signals. One's going to be connected to trigger, the other is going to be connected to RF signal, and just note that the BNC connection here, whatever one that is, the label is going to be listed directly underneath it. Dr. Mull was laughing because that's kind of confusing. So, for example, trigger, right?
That's right. Trigger
the connector is going to be above the word trigger, okay?
Right.
And then I'm going to show you how to do the exact same experiment using the software on the computer. So I actually already have it set up. What we have is one of our transducers, and this is what a transducer looks like. All right, it has some crazy connector at the end that they're calling a LEMO connector. I don't know, you can kind of see in there, it's kind of just a proprietary connector that the equipment uses. That's going to go ahead and connect to either the receiver or the transmitter probe outlet. For this experiment 3, we're going to be using one of these transducers as both the transmitter and the receiver. And what we're going to do is we're just going to put this transducer, which by the way, this business end of the transducer is very delicate. You're going to want to make sure you don't slam it off the floor of the table or put something sharp against it. You're going to want to take care of this end. Okay. What we're going to do in this experiment is we're going to take some signals and send them into a piece of material. So Dr. Mulhall over here actually has one of the transducers already set up, ready to go. What we're going to do is we're going to send a signal from that red transducer into this clear piece of acrylic. Now notice, we have to make a good connection between the transducer and the acrylic, so we're going to be using this stuff. It's a transmissions gel, which makes the connection even better. So you kind of just put a little glob on there and make sure there's a good connection between the transducer and the piece of acrylic. All right. So I already have my settings on the oscilloscope ready to go. You're going to have to walk through all the instructions, go through them step by step to get to the place where we're at in this video. So when I go ahead and turn on our ultrasonic echo scope, we're going to see 2 signals pop up on the oscilloscope. All right. This is the starting point for actually starting to send a signal. Right now, I have the transmitter at 0, meaning I'm not actually sending anything out, all right? And I also have the receiver settings at 0, so I'm really not going to pick up anything either. So this is what I want you to do. The original signal here is going to be this blue blip that you see, which is connected to channel 2, all right? As I increase the transmitter knob, you're going to see the signal is increasing, and I'm going to max it all the way to 30. Now, you might be able to tell, but you can see a little bit of a blip up around right here. But as I increase the receiver amplification, essentially, you're going to see that I'm going to get a signal. Okay? So I have my original signal here that's going into the acrylic block. It's moving toward the other side. There's a reflection on the other side of the acrylic, and then it's coming back, and that same transmitter is also receiving the data back as well. All right. Now, the time it takes for that back and forth motion, so our total round trip is going to be the time between those blips. So if I move the position here, each one of these blocks horizontally is 10 microseconds. So if I count the number of blocks between blips, I have 1, 2, 3, 4, 5, 6. So it looks like the total round trip time is 60 microseconds. Now you're going to have to figure out how to, why is that significant and throughout the actual experiment. So this is how you do it here with the oscilloscope and ankoscope. And if you want, you can try a different block. So let's try a different block.
This one's half the length.
Half the size. So we'll see if that affects where the signals are.
I'm going to get a little bit of transmission gel here onto it. Try and get a good contact.
Ah, look at that. So I'm going to drop the receiver amplification down a little bit. Maybe I'll leave it up a little bit because now look, we're getting 3 signals. We have the original, we're getting 1 reflection, and then we're getting a second reflection. How about that? That's pretty cool. Now, let me move this just so we get it to, actually that's actually perfect because look, now for the half length cylinder compared to the first one, our signal back and forth time, our round trip time is only 30 microseconds, and then we get another 30 microseconds, we get a third signal, okay? So you're gonna work through a bunch of experiments dealing basically with that equipment. Now you can also do this with A-Scan, which is a piece of software on the computer. I'm gonna go to All Programs, and then go to GAMPT, and then choose A-Scan. Now this piece of software is going to do basically essentially what the oscilloscope does. So Majid, could you get a side-by-side here? So you're going to see at 0 is our original signal, just like here was our original signal on the oscilloscope, and you're getting the same thing here. So look, you're at 30 microseconds, right at 60 microseconds. So you're going to do the same type of experiment right here with the software. It's just that the software just kind of gives you the answer. We want you to learn more about using the equipment in this modern lab, so that's why we're having you also do it on the oscilloscope. Now there's one more cool demo that we're going to show you in the video, and I'm going to send it over to here to Dr. Mahal. This is another feature of the software that you really can't do with the oscilloscope, but it's a really cool thing. So he'll describe what this big black block is over here.
So this is there's a mode with the software where it gives you a waterfall graph, where we'll see a beam. Could you just actually hit A mode?
We're on A. You want B mode?
B
there?
mode,
B
yeah.
mode. There we go.
Now, can you hit start?
Sure.
This is called a waterfall, and you see as you go down, that's in effect that's distance. So the signal went down, and at this sorry, this is time. At this time we received an echo, and here's another echo. So if you look at that gap, that tells you how far through the medium the reflecting object is. So the reflecting object in this case is this end here. This is an abrupt change in density between acrylic and air. So this change in density reflects the ultrasound, and the ultrasound goes back like this. If I replace this, actually let's do this for a laugh. Can you hit stop and start again?
Sure. Ready?
Yep. Now I'm gonna do this. And nothing happens because I needed some gel. That's okay. Let's do something even more cool. Let's do this. Suppose I start here.
Ready?
Ready, go. There's something scattering shallow. Oh look, there's scattering objects. Hold on a second. Sorry, I had a bad connection. Can you go again?
Sure. Here we go. Go. Oh, that's better.
There.
Look at that.
Look
See
at those
these blips?
They're scattering objects closer and closer to the surface as I scan along this thing. Look at those blips. So there's something inside this block that as I move along, there's an abrupt change in density. I don't know, is it becoming more dense or less dense? I don't know. It's a detective thing though. You could figure out this is made of acrylic, so you should know what the density is, what the mass of this is, and maybe there's holes drilled in it or something like that. But there's something causing the ultrasonic waves to echo back. There's an abrupt change, there's an interface, a change in density. Changes in density are very interesting for ultrasonics because they detect kidney stones and tumours and stuff like that. So the biophysics majors will be particularly interested in the behaviour of this. And these waterfall graphs are good for when you're doing like just searching around to find out is there something inside a sample, and there'll be more on that in the experiment.
All right, that's everything. Michael Faraday, write that timestamp down. See you later.